This video is about the length of the intersection of two surfaces. So here's the question from WebAssign. It says, let C be the curve of intersection of the parabolic cylinder x squared equals 2y and the surface 3z equals x times y. Find the exact length of C from the origin to the point blah blah blah. And here you can see the answer is supposed to be 385/6. So this can be kind of a challenging question. So let's just use Sage to look at a picture of what they're talking about. So this yellow color is 3z equals x times y, and the pink color is x squared equals 2 times y. And if you plot them together in the same three-dimensional frame, then you can see their intersection. So there it is. Alright, and so what we really need is some kind of equation that somehow describes the line of intersection. And, you know, the flash of insight or whatever that goes along with solving the problem is to realize that you can describe that parametrically. So how can you do that? So you have two equations. One is x squared equals 2y. The other equation is 3z equals x times y squared. Shoot, did I mess this up again? I did, didn't I? Yeah, so I did this problem wrong once because I invented that square. Let me just get rid of it. Okay, so sorry, that's kind of confusing, huh? So the two equations that we care about are x squared equals 2y and 3z equals xy. And this work is actually for that. So you can just let t be the parameter, set that equal to x. And then because of this equation, you must have y is equal to t squared over 2. And because of this equation, then just plugging t in for x and t squared over 2 for y, and then dividing both sides by 3, you get that z has to be t cubed over 6. And now you can plot this line together with the two intersecting surfaces. And there it is. You can see it's sort of that red line there. And so to answer the question, what we have to do is find out how long the red line is. And there's a little bit I guess I'm skipping, is how do I know that I care about this parametric line between t equals 0 and t equals 7? The way I know that is if you look in the statement of the problem, it's so the origin is the point 0, 0, 0, right? So that tells me, if you look at the parametric formula here, the only way this can be 0, 0, 0 is if t is 0, so that makes it the origin. And similarly, how can that parametric formula describe this? Well, obviously you have to just let t equal 7, right? So that's how I know that I need to look at t between 0 and 7. So here's the pretty picture, and now let's actually do the calculus. So, you know, r is the position vector, and then r prime is just the derivative of r with respect to t. Now you need to take the norm. This is because the formula for arc length is the integral of the norm of r prime, right? Just remember that formula. So that's what I'm doing here. So this is what r prime is in this case. And now I just take the definite integral of the r prime norm from 0 to 7. And that gives me this answer, which is 64, and we should check that against the answer that WebAssign claimed was the answer, and they agree. So that's it.